Hello, we are discussing about GATE 2005 ECE paper, and this question is related to analog circuits. This question is given as a common data question which consisting of three internal questions. So this is the first one, second one and third one. This common data questions consisting of three more questions. Okay, and look at the circuit diagram given with JFET. For the given circuit, given Rd is equal to 20 kilo ohms, Rd is nothing but internal drain resistance. Small Rd is internal drain resistance. IDSS, drain to source saturation current, which is going to the maximum drain current flowing through the drain to source. So this is going to be IDSS is given as 10 milliamperes. Vp, pinch of voltage, is given as minus 8 volts. First question asked about the ID and VDS under DC conditions. That is DC drain current and DC drain to source voltage. ID and VDS are going to be, we are going to calculate. And second question is nothing but what is its equivalent input resistance and output resistance. If you are looking into the terminals shown, ZA and Z0 are going to be shown on the diagram. What are their values? You have to calculate. And third one is nothing but we are going to calculate voltage gain of the amplifier along with transconductance. Okay, first we will see one by one. DC conditions. Under DC conditions, remember that one. Under DC conditions, that is whenever you are considering DC conditions, at that time, that is nothing but you are going with only DC voltage, that you can say it as DC analysis. Under DC conditions, capacitors acts as open circuits, because for DC is nothing but constant. For that one there is no variation, so that no oscillations, frequency is going to be 0. Okay, so for DC signals we will always assume frequency is going to be 0. By that time, if you calculate reactance XC, capacitance of reactance is nothing but 1 by 2 pi FC. So F is equal to 0. So something by 0 is nothing but infinite. Infinite is nothing but capacitor act as open circuit. Okay, so that implies nothing but this capacitor act as open circuit, this capacitor is also act as open circuit. Now the circuit consisting of only this much. This is a portion of the circuit related to the DC analysis. Okay, so that portion we will draw now. From that one we are going to calculate ID and VDS. Okay, the portion of the circuit available is this one. This is 20 volts and it is 2 kilo ohms, and next this is connected, and over here it is this is connected to ground, and here it is 2 mega ohm, and this is nothing but 2 volts minus plus. Now identify the terminals. This is gate terminal and it is drain terminal. This is source terminal. We are going to calculate VDS, implies nothing but from voltage across drain to source, and current flowing through drain is nothing but this one. So these are the values we are going to calculate. ID is nothing but current flowing through drain. Remember that one, always the current flowing through gate is going to be 0, because whether it is going to be JFET or MOSFET, the only one important point you must remember is nothing but always gate current is 0. In case of JFET, gate source junction is always reverse bias for the amplifier applications, so that under reverse bias very small currents flows, so that they can be treated as 0. So IG is equal to 0 in case of JFET because of reverse bias gate source junction, whereas in case of MOSFETs, gate is isolated by the SiO2 layer from the drain and source. Gate is isolated from drain and source by using a silicon dioxide layer, that is SiO2 layer. Because of that one, no current is flowing from the gate to drain as well as source. So that gate current is 0 in case of MOSFET because of silicon dioxide layer which act as insulator, and in case of JFET, Gate current is 0 because of reverse bias gate source junction. Okay. Now, with the help of Ig is equal to 0, can you calculate VGS value over here? VGS is nothing but voltage from gate to source. Okay. Apply KVL. Apply KVL across gate source junction. Gate source junction. So gate source junction is nothing but this one over here. So from this one you can write it as -2, okay, and minus Ig times of 2 mega ohms minus VGS is equal to 0. Since Ig is equal to 0, this term will be equal to 0. So what you are going to get is -2 minus VGS is equal to 0. From this one you can write VGS is equal to minus 2 volts. And we know the drain current for the drain current equation for the JFET. ID is equal to IDSS times of 1 minus VGS by VP whole square. Okay, IDSS is given as 10 milliamperes, 1 minus 2 divided by minus 8. VPP is given as minus 8 whole square. So this will be equal to 10 minus 1 by 1 by 4 whole square. So this will be 10 into 3 by 16. 10 into 3 by 4. 3 by 4 is nothing but 9 by 16. This will become 9 by 16. So the value of this one is going to be around 5.625 milliamperes. 5.625 milliamperes for the ID, and VDS voltage from drain to source is nothing but VDD minus ID times of RD. So VDD is 20 minus ID is 5.625 into RD value is 2 kilo ohms. So this is around 20 minus 11.25, 20 minus 11.25, which is around 8.75 volts. So ID value is 5.625 and VDS value is 8.75. From that one we can say the right answer for this question is A. 5.625 milliamperes and 8.75 volts. Now we will consider about the second one. Okay. Second one, we are going to calculate Zi and Z0. That implies nothing but Zi and Z0 is nothing but we are going to perform AC analysis. AC analysis. For AC analysis, you must consider two important points. One is nothing but external capacitors, that is microfarad capacitors. Microfarad capacitors act as short circuits. Acts as short circuits. Microfarad capacitors are act as short circuit, and second one is nothing but DC voltage source is going to be grounded. DC voltage source is grounded. While drawing the AC equivalent circuit, you must consider these 2 points. Okay, because we are going for the AC analysis, that is we are applying input signal. Input signal will have some frequency. We assume that one at that frequency, at that input frequency, these capacitors act as short circuit. Okay, and second one is nothing but DC voltage source is grounded. Why the DC voltage source is grounded for AC analysis? Okay, AC analysis is nothing but you are applying a small signal at the input. Small signal is nothing but small variations at the input side. That variations are going to making variations in the circuit nodes, that is nothing but circuit currents and circuit voltages, but that doesn't make any variation in the DC voltage, because DC voltage source is a constant power supply. In that one there will be no variations. So the variations only we are considering for the AC analysis. AC analysis is only related to the variations produced at circuit nodes, that is circuit parameters, but there is no variations, there is no change. That change is nothing but zero change. So zero change is nothing but it is treating as DC voltage source is going to be connected to ground. In other way we can say that one. This is one method. one way of saying why DC voltage source is grounded. The other way of saying is nothing but this circuit is now consisting of two sources. One is DC voltage source of 20 volts, the other is AC voltage source of VI. Okay, so that implies nothing but whenever a circuit consisting of two or more sources at that time, overall response can be easily calculated by using superposition theorem. Superposition theorem says the overall response is going to be calculated, okay, by adding individual responses. Individual responses is nothing but output due to each individual source. Whenever you are considering individual source, all other sources will be treated as not connected to the circuit. If they are voltage sources, they will be get shorted. If they are voltage current sources, they will be get open circuited. In that way, as you are going for the AC analysis, you are considering only AC source. By that time, the other source, that is nothing but DC, should be connected to ground. So these are the ways we can say why the DC is going to be grounded for AC analysis. Okay. Now draw the equivalent circuit. Then we will identify what is meant by Zi and Z0. Okay. So look at this one. So we have to draw the AC equivalent circuit for this one. AC equivalent circuit can be drawn for this one. This is what gate and it is source. This is what drain. So first we will draw this one. This is what gate and it is drain and it is source. Source is directly connected to ground, so that we are writing it as source, and from drain to source there is a current source which you can write it as GM VGS, and one more resistor over here since it is RD is given, otherwise you can omit this one. RD is going to be a resistor. So this is what drain and it is what gate and this is what source. So this is the circuit diagram, internal circuit diagram or small signal model for the JFET given. So this we can say it as VGS plus minus. Okay. Now we have to add other circuit parameters. Other circuit parameters is nothing but gate is connected to 2 mega ohms. Gate is connected to 2 mega ohms. So this is what gate. Gate is connected to 2 mega ohms and a DC power supply 2 volts. But DC power supply is going to be acted as ground. So you can think that 20 volts is going to be treated as ground as well as 2 volts is also treated as ground. Because in DC there will be no variations taken place even though you are applying AC signal. So that this is 2 mega ohms. 2 mega ohms. And it is going to be connected to input signal Vi plus minus. Okay. Now if you think VGS can be directly say it as Vi. VGS is nothing but Vi. You can write. And Zi implies nothing but Zi is nothing but this is what given. Zi is going to be the input resistance whenever you are looking into these two terminals. So this is what Zi. As you are looking into these two terminals. As you are looking into these two terminals, only one resistor is seen whose value is 2 mega ohms. So that is nothing but 2 mega ohms itself. Because input side gate source is going to be act as open circuit because of reverse bias gate source junction. Always gate source junction is reverse bias for the JFET amplifiers. So that input side it will be act as open circuit. The only resistor you have connected is 2 mega ohms, that will be the input resistance Zi. Now you have to connect the other things. Drain is connected to ground through 2 kilo ohms. So this drain is going to be now connecting through 2 kilo ohms towards ground. Okay. So now the Z0 is nothing but this is where you are going with the V0 plus minus. So now you are looking into these two terminals. Z0 is nothing but the parallel combination of these two resistances. Because whenever you are calculating equivalent resistance, by that time current sources if any present they will be act as open circuit, voltage sources if any present they will be act as short circuit. so that this current source now act as open circuit while calculating the effective output impedance. So that only two resistances are present, they will be in parallel. So Z0 is equal to RD, that is 20K parallel with 2K. So it will be 20 into 2, 40 divided by 22, which is nothing but 20 by 11 kilo ohms. So Zi value is 2 mega ohms, Z0 value is 20 by 11 kilo ohms. So the right answer for the second question is, okay, Zi is 2 mega ohms, Zi is 2 mega ohms and Z0 is 20 by 11 kilo ohms. So the right answer for this one is B. Now we will calculate the transconductance and voltage gain of this circuit. Okay, transconductance can be written as, transconductance is nothing but Gm, which is nothing but, okay, transconductance is indicated as Gm, which is equal to 2 IDSS, 2 times of IDSS divided by modulus of Vp into 1 minus VGS divided by Vp, and given as IDSS. IDSS is going to be given as 10 milliamperes. So 2 into 10. 2 into 10 divided by Vp is nothing but minus 8, but we are only calculating magnitude, so that 8 into 1 minus minus 2 divided by minus 8. That is nothing but 1 minus 1 by 4. 1 by 4 is nothing but 3 by 4. So 20 by 8 into 3 by 4, which is equal to, Gm is equal to 1.875 millisiemens. This is what transconductance. Now we are going to calculate voltage gain. Okay, from this one V0 can be written in this way. V0, output voltage V0 is equal to, V0 is nothing but, if you write this parallel combination of two resistances as a single one, okay, by that time this is going to be the current flowing through that resistor, but it is the current flowing in opposite direction. You can write it as V0 is equal to Gm times of VGS multiplied by 20, that is RD parallel 2 kilo ohms, that is nothing but 20 by 11 kilo ohms. You can write 20 by 11 kilo ohms. So gain is equal to, voltage gain is equal to V0 divided by VGS, and VGS is nothing but Vi from this circuit. So V0 divided by Vi, which is nothing but Gm times of minus Gm times of 20 by 11 kilo ohms. So Gm is going to be, just we have calculated, that is 1.875 millisiemens multiplied by 20 by 11 kilo ohms. Milli and K get cancels. What you are going to get is minus 3.41. So this is what the voltage gain of this circuit, minus 3.41. So the right answer for this third question is nothing but minus 3.41 and 1.875 millisiemens. So the right answer for this question is B. Transconductance is 1.875 millisiemens and voltage gain is minus 3.41. Thank you.